Hi, welcome to Chapter 2 of Deep Learning Mathematics and Theory, the comprehensive online course to go with the textbook Deep Learning by Ian Goodfellow, Joshua Bengio, and Aaron Corville. In this chapter we talk about linear algebra, which is a critical mathematical concept that underlies much of deep learning and machine learning theory. The tools we learn in this lecture will be used throughout the course, so it's important to understand everything. This chapter is geared towards people with some familiarity with linear algebra, but might be a bit rusty, so we'll be going into great detail to explain all the critical concepts in linear algebra, so the rest of the course makes sense. Let's quickly go to the computer just to check out what we're going to be talking about throughout this chapter. Alright, so this is just the table of contents from the Deep Learning textbook, but since we're using their textbook, it's pretty much the same thing as we're going to be following. You might notice that there's 12 subchapters for this chapter 2, linear algebra, but I've put up around 20 lectures for this chapter, and that's just because for a few chapters here that I've kind of given a few additional lectures to provide some extra insight if you need it. For example, in 2.7, instead of just talking about eigendecomposition, I give a couple lectures giving some prerequisite understanding on things like eigenvectors and eigenvalues, and I also squish in some more stuff that's not here, like positive definite and positive semi-definite matrices that might come in handy later on. And I encourage you to watch all of them, because it'll make things a lot easier later on. If you're following along on YouTube, you just have access to the lectures, but if you are just on YouTube, I highly encourage you to enroll in the course because it's completely free, and that means you'll have access to the quizzes in between some of these lectures, as well as there's a few articles here and there that I've attached to learn a little bit more about some of these things. We'll go a little bit more deeper in a few of these topics, like for example Gaussian elimination isn't covered here, but if you want to go a little bit deeper there, I have an article for that. But otherwise we're basically going exactly by the book. Each of these sub-chapters here we have a lecture that's tied to it, or more than one. So the first lecture we just introduced, so the next lecture we introduce the basic mathematical objects we'll be dealing with in linear algebra, so those are scalars, vectors, matrices, and tensors. And the first couple of lectures are just talking about some basic operations we can do on these matrices and vectors. 2.4 is the first kind of difficult lecture where we first introduced some uniquely linear algebra ideas like linear dependence and span. So that's a bit of a long lecture, but it's one of the most important ones here. 2.5 we talk about how we can measure the sizes of vectors and matrices in these mathematical objects, and so that's critical important as well. 2.6 is an easy one. We just talk about special kinds of matrices like symmetric and diagonal matrices, which should be ringing a few bells, because again, we kind of expect some prerequisite understanding in linear algebra, even though this introduction is pretty comprehensive. 2.7 and 2.7 to 2.9 I consider kind of the monstrous part of this chapter here. Those are all big subchapters. Eigendecomposition, I have 5 different lectures for it because I cover a lot of different things in there. So this is kind of the big part of the course because these are 3 of the most important ideas in this, and they're also 3 of the most kind of complex ideas here, but they'll be simple as long as you understand the stuff before it. 2.10 is easy. It's a nice break. It's just a really simple lecture. You'll enjoy that one. And 2.11 is where we just talk about the determinant, which if you've taken a linear algebra course before, this might be weird seeing it at the end and kind of as a footnote here, but the text for it in the textbook is literally about a paragraph, because we don't really use the determinant too much in machine learning, so it doesn't play that big of a role, so we don't really talk about it too much. 2.12 is basically an example that ties together all the things we learned throughout this entire chapter, but I don't have a lecture on it because you can basically just follow along with the text in the textbook, because you're basically just going through a few computations, and I think it'd be pretty pointless for me to do a lecture on it because I'd just be going through those exact same computations. That's about it. That covers everything in the linear algebra chapter. I hope you enjoyed. It's a really important chapter to understand the rest of the course. So I encourage you to watch all the lectures and take your time, take notes, and all that good stuff. All right, I'll see you in the lectures. Bye.